Hi, good afternoon. Welcome to the talk. I'd say it's good to see so many people here, but I cannot see anything. So if you want to sneak out at the back, I won't know. Today, I'm going to run you through what I think are kind of 7 deadly Gopher sins. Don't take it too seriously. A lot of these are going to be things that I've been guilty of myself, or things that I've run into over my career. And hopefully it can help you maybe not make some of the mistakes I did. Some of these are going to have like a few little examples. Some of them are going to be rambling anecdotes, quite frankly. But they're all going to come with Gophers. To begin with, very quickly, who am I? I'm John. I'm a senior engineer at Admiral Money. I do various things. But you probably don't really want to hear about me because you're not really here to, sell me as such. You want the Gophers and you want the sins. So, without further ado, and because we all love Go, I hope we all love Go, that's kind of why we're here, otherwise you may have come to the wrong conference. Let's open with lust. But, of course, I'm not talking here about a sin of loving Go too much, because we'd probably all be kind of guilty of that one, and I think that's quite fine. So what am I talking about? Well, just for a moment, let me take me back to childhood. And probably for me, that's a bit further than some of you. But remember when you were kids and you saw that advert on TV for that, super cool new toy? The one with all the really whizzy action features and smooth transforming action and lights and sounds and all the rest of it. And if you were lucky, someone bought it for you. But you got it home and you rushed to play with it and you were really excited, and it didn't quite live up to your expectations. Maybe some of the things in the advert weren't quite, as sold. Maybe that smooth transforming action actually took 20 minutes and involved an Allen key it didn't tell you about. Well, what's that got to do with Go? For some people, Go is that toy. Whether they're coming potentially from an existing engineering background and they've got some problems they just want to solve, or they're new to Go altogether and they think, Go's a good place to start, which it is. In those cases, they see Go, they see its fantastic features, and so they want to jump in, and they want to get started. And that's great. And of course, if you're going to start off with, some hobby projects and things, and maybe some proof of concepts and learning the language, not a problem. But the sin comes in when people rush in to maybe use these things too early into production. Because of all the things Go is, it's sold as very easy to use. And in the most part, it is. It's a really easy language to pick up. But let's start with a quick illustration, I guess. Of all the things in Go, of all the things that tempt people in, of all the super cool action features that Go has, probably the headline one is concurrency, and specifically concurrency with Go routines. And things all kind of start with how they're sold. I'm sure we've all seen the sales pitch, where we have something like this, and it'll be like, have you got slow, boring functions? Do you want really easy concurrency? Do you want to not have to worry about thread pools and scheduling? Just add the Go keyword. Job done, right? Except that's not totally true, is it? It's technically correct, which, as we all know, is the best kind of correct. But it's not the whole story. And to further illustrate, let's say you're that new Gopher, and you've written a bit of code like this, which is, fairly straightforward loop that just sums some numbers together and happens to convert them from strings to numbers in the middle. But you think, this is Go. We should be using Go routines. So you do. And all of a sudden, your code is now twice as long. Now you have to start introducing concepts such as channels. You can't just return errors from your function in the way you did before. Now you've got to put in waiting patterns, because if you don't, it's not going to actually do anything before the rest of your code exits. So what's the quick takeaway from this one? Well, again, I'm not going to say, I'm not saying Go routines are bad. Of course I'm not. There are some fantastic talks just this conference about how you can use them in amazing ways. It's just more about being a little bit more cautious, because it's very easy to get sucked in and think, I want to play with that fantastic toy, and potentially get yourself into problems in production with complexity and bugs that are really, really hard to deal with. So let's then jump to the other end. Let's go from lust to wrath, or wrath, or however you want to pronounce it. Technically a bit like that, but. And this one is probably best illustrated. So who out there has read Hitchhiker's Guide to the Galaxy? I suspect probably a lot of you. It's that kind of audience. I mean, I know I have. Who remembers what it says on the front cover? Don't panic, exactly. By which, of course, I'm referring to runtime crashes. I don't mean just running around your office screaming because you've run out of coffee or something. But, of course, by don't panic, I'm not saying the sin here is to fail to write absolutely perfect code, because that's kind of mathematically impossible. The sin here is more about falling into the trap of relying on panics as an error handling strategy instead of using checked errors or defensive code. Because I like to use this analogy. Using panics instead of checked errors is like trying to stop a car with a wall instead of using the brakes. Because both scenarios work. Both scenarios achieve your goal. You stop the car and avoid the cute little kitten that's walked out in front of you. The difference is, in one of those scenarios, you get to get out of your car, pet the kitten, move it outside the road, get on with your day. In the other scenario, you're picking bits of your car out of the wall. And it should be fairly obvious which one is probably the more desirable outcome. But even then, probably the bigger sin, is intentional panics. And these are quite easy to do and quite easy to catch a lot of people out, especially people new to Go, and I've seen it happen, with a pattern called must. And this is one, especially if you're new to Go, you may not have come across this, or you might have just seen it in some Go docs, and you don't really necessarily understand it. Basically, there's a convention in Go, and I stress it is a convention. It's not magically enforced or anything. That if a function is prefixed with the word must, instead of returning a standard error type, it will panic if it errors. Now, you might immediately be going, why would I want to do that? You've just told me never to panic. And there are uses for it, as we'll see in a minute. But one of the biggest sins is misusing it like this. Because people read must compile, in this case it's regex must compile, and assume that means it can't fail. But what's actually happened in this example? Well, here we've got a fairly straightforward handler. It just reads a value from the query string, attempts to run a regular expression from it, and takes some action based on what the string was, which is fine. And if you've made no mistakes in that whatsoever, there is no problem. I mean, it's not the most efficient way of doing it, because that regex now gets compiled every single time your handler runs, and it's not changing. But it's not a problem, because it works. But what happens is if you've made a mistake in that regex before you push this code, the first time you're going to know about that is when a user tries to call your service. And instead of getting a nice error, a nice, sorry, we can't handle your request at this time, or some default response, they're probably going to get some kind of bad gateway. And depending on what kind of deployment system you've got for your service, you might now have a dead service as well. What you probably wanted to do was something like this. Because here is where must actually is useful. Because now we're only compiling that regex the once. And importantly, we're compiling it at startup, first compile time. So if there's something wrong with that, your service will never start in the first place. And if you've got a nice, rolling deployment system like Kubernetes, for example, that means your old service may just stay in place, and this will never roll out, and your customers will never see any detriment, which gives you a chance to fix it, which is obviously more desirable to, your customers finding out, because you want to know your service is broken before they do. And of course, we have the bonus that it only gets compiled the once. So how do we avoid wrath? Always prefer checked errors to panics. Only use recover as a last resort, because recover is a thing. And I think it's already been mentioned, potentially, about using recovers as a kind of try-catch. You can do that. And if you've got some absolutely really must-not-fail code, like some really key database transactions you need to make sure roll back if something outside of your control happens, great. But don't do it as a matter of course. And then, if you must use must, always be aware of what they actually do and be aware of when you're running them. Because, again, you want to know something's wrong before your users do. So how can we be greedy in Go? And this isn't just about writing as much code as possible or, trying to own every single service in your company. Well, they say you can't be too prepared. But is that really true? Because none of us can see the future. I mean, beyond certain bounds. There are some reasonable expectations, like I can fairly predict there are going to be some more awesome talks over these couple of days. I can reasonably predict I'm going to go and grab some more coffee after this. But then we get into the unknown unknowns, which we can't predict and we don't even know what they could be. But in engineering, we have a habit of attempting to do just that and try to anticipate those. And I know you're going to be probably shouting at me out there. I can't hear you in the dark. I know that's not a thing. What's wrong with writing, future-proofing and writing flexible code? Not looking at anyone in the audience. Well, ultimately nothing, of course. And if we're sticking with our known knowns and our known unknowns, fine. The problem comes when we try to preemptively over-engineer and potentially over-genericize a solution in a misguided attempt to potentially deal with everything. Because if we solve it all now, we don't have to do anything later. And the best way, I think, to explain this is with a ridiculously oversimplified hyperbolous example, as you'll probably get used to throughout this talk. Say, for example, you've got a service, and all it needs to do is return your company motto, which, for sake of argument, is Hello World. That's fine. We can just solve that with format println Hello World. Now, we have a reasonable expectation that our motto may change at some point in the future, and that's fine. Our solution, accounts for that. We just go in and change the string. The problem comes when we then start overthinking. Because what if it's not us that is going to make that change? What if we want a non-technical user to do it? Maybe we need a CMS. Maybe we should start putting stuff in the database, because maybe that's good practice. What about internationalization? I mean, we don't deal with any other languages at the moment, but we might do in the future. Maybe it's not going to be a string at all. Maybe we should use generics. Maybe it's going to need to use some AI optical character recognition and like read a JPEG or something. Maybe we should just build an authentication system into it. We don't need one now, but you never know. And then very quickly, your nice, simple, crafted microservice becomes a beautifully engineered monolith of what you think is a perfect solution. Right up until the first bug comes in, or the first big feature change. Because let's say your customers suddenly report that it's not saying hello world, it's saying hello world. Whoops. Well, in our first solution, all we do, we jump into the code and we change the string. It's a quick change. But what about in our new behemoth unicorn? Suddenly we can't find the string, because maybe it's not a string anymore. Maybe that string is now split up over 20 different databases and 6 different systems. Maybe it is a JPEG of a handwritten note that sat on somebody's desk with a webcam pointing at it, because we never know when the boss might want to change it. And now a 30-second change or debug is potentially a 6-month rewrite, because we tried to get too clever, because we tried to step beyond those known unknowns. And again, before you think that is too much of a hyperbolous example, sure, not hello world, but I have generally got experience of these things happening. And yes, I have definitely been guilty of doing that myself, trying to write a perfect system, only to find I've over-engineered myself into a corner. Because suddenly your incredibly flexible system doesn't like you anymore. And just as a segue into generics, and again, there have been some fantastic talks already on generics, and generics are great where they are useful. I do use them. Only use them when you need them. Don't think they're going to save you or actually make your code fully generic. That's not really what they're for. So just think through whether you need something before you try to implement it, because it may actually hurt you rather than save you time. But after all that panicked, over-engineering, rushing around trying to make the best service possible, and consider it's the afternoon now, let's drop into a bit of sloth. Now, you've probably heard that laziness can be a virtue, especially if you've come across Larry Wall's 3 virtues of a programmer: laziness, impatience, and hubris. But you may have thought to yourself, well, how is that possible? Because surely if I'm lazy and I just, don't put the effort into writing my code, well, how's that going to help? And it isn't, because that's not what it means. It's one of those, again, technically correct, but entirely misleading statements. So let's segue into yet another overly simplified hyperbolous example. And it's one we've all come across, and we've had probably drilled into us from the moment we started coding, which is commenting. Now, this is I would wager, incredibly simple piece of code that anyone who knows Go, or even any other language, can probably have a reasonable stab at figuring out. Just takes a variable, adds 1 to it. But that's not the problem. The problem is why. We all see what it's doing, but we don't know why it's doing it. And of course, you think, I know, I'll be a good programmer. I'll add comments. Oh. I've definitely come across this, and I've definitely been guilty of this on my lesser caffeinated days. But it doesn't help. And if anything, it makes things worse, because now we've got less white space, we've got more cluttered code, and we've just wasted effort. What we wanted was that, with a potential judicious can't say the word, but you know what I mean, better renaming of the variable in the first place to make it more semantically relevant. Because maybe this code is in the middle of a bigger function that, say, reads from an API and then stores some data to a database, and arbitrarily, seemingly, changes some of the fields in the middle, like increments some counters or changes some dates. We need to know why, because that may not always be true. And in 6 months' time, when you come back to it and you go, why does it do that? Future you is going to thank you for doing this. This has saved me on many, many occasions, especially when your context shifting around a lot. You think you understand it now. Future you probably won't. But we've all, seen comments. We've all been taught best practice of comments, even if we don't do it, because we're potentially sinfully lazy on occasion. But what about errors? Now, we've probably all seen this bit of code. We've probably written it 1,000 times. And as with some other things I've covered, there's nothing wrong with it. Except, if error not equals nil, return error. I mean, that's a Go idiom. That's how you handle errors. Or is it? Because is that actually handling the error? Or is it just going, which is kind of fine, because we can't definitively handle every error at source. Sometimes we do have to bubble errors back up to whatever called us. And if this was, say, at the top level of your code, or one level down, yeah, fine. Because, say, we need to unmarshal some JSON, we chuck it to a slightly custom decode function that maybe does some other stuff. But if we get a JSON error back from that, so what? If we see, invalid character at start of blah, 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 we know what it was doing, because we know it was unmarshaling JSON. But what happens if this is 6 or 7 layers deep? What happens is if we don't even know we're supposed to be unmarshaling JSON. Because we just make a call, and somewhere down in that stack, it goes and reads some configuration that happens to be stored in JSON, and then unmarshals it to do something else before it gives us the result. When we suddenly see an error that says, invalid character at start of blah, 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 we go, what JSON? I'm not doing anything with JSON. And maybe there's several different points at which JSON could be being unmarshaled. How do we know which one went wrong? So what we want is to add context. And by context, and pretty much every time I say context during this talk, I mean semantic context, not the context package. We don't have enough words. But a simple way around this is to wrap the errors before you return them with extra semantic context. So in this case, this particular bit of code was decoding customer data. So we tell the caller that we were decoding customer data and then what went wrong. Also, by doing it like this, there are many patterns for wrapping errors and doing things to pass it back. But using the percentage %W means we get a nice breakpoint in the stack at that point and allows us to unwrap those nested errors. So if we're using potentially Bastion-type errors, we can easily go through and say, was it of this type? Was it of this type? Did this happen? And by the time that then gets back to the caller, we have a nice, basically, story of what happened. So you don't then have to pick up your debugger. You don't have to start trying to trace through your code. You literally have a string of English, or indeed your chosen language, that says exactly what went wrong down the stack. But again, don't fall into the trap of the previous comments of just going unmarshal error, because that didn't actually add anything. So it should go without saying, because we've probably, again, all had it drilled into us, with comments, make sure you explain the why, not the what. And it is hard, because it does make you think, and usually you have to think a lot harder about the comments than you do about the code you wrote. But future you will thank you. And anyone else who joins the team later won't then curse your name. If you do allow errors to bubble, because you can't handle them definitively at those levels, add context. Just make sure the caller knows what was going on, what you were attempting to do. And again, not just the what, but the why. And ultimately, yes, don't skimp on effort now to make your life easy later. Mindful of the previous sin of overengineering. There is a middle ground. But this is more about cognitive load, about making it harder to think about and understand rather than literally making the code just more complex for no reason. So, what's our Gopher sin of gluttony? Well, I'll take another little segue into analogy. You know when you go on holiday, or, come into a conference like this, and you get there, or, even by the time you get home, you realize you packed way too much. Your suitcases are heavy to lift. If you had to fly somewhere, you probably had to pay extra. And that one pair of socks that you needed, you had to unpack your entire case to actually find it. And probably even worse, you realize you didn't need half of it. Well, what's probably happened, and again, this is overly hyperbolized. Maybe you don't do this, maybe it's just me. Maybe you're used to, for example, always going on 2-week holidays to the Bahamas. So you always naturally pack your swimming stuff and your snorkel and your sun cream, your standard holiday stuff. So when you go anywhere, you just reflexively pack it. So after all that, you get to London for a 2-day conference and wonder why you brought the snorkel. I mean, it rains in London, but it's not quite that bad. And at this point, you're wondering, why am I rambling off about holidays and packing? Well, similar is true of our use of libraries and frameworks in Go. Because just like those things you've packed, the vast majority of them are incredibly useful in the right situation. If you're going snorkeling, that snorkel is really useful, and it's the right tool for the job. But if you're just going to wander around some London museums, you might get some odd looks. So the sin here isn't using libraries and frameworks in general, because they are useful, they are incredibly powerful, they do lots of things that you possibly can't do yourself or shouldn't do yourself, like rolling your own encryption. But the sin is reflexively using them out of habit, just because. This is one, I think, that's very prevalent in people who have possibly recently come from another language. And again, kind of thing I almost certainly did when I started using Go. Because in other languages, say Java, for example, it's tempting to say, right, here's my framework, what's my problem? Rather than, here's the problem, how do I solve it? And even in Go, you might have a favored framework, for example. You might like using Echo or Go Buffalo or something. And you need to write a web service, so you just reflexively import it and use it. But do you need it? And again, I hear you cry. Why is it a problem? Because, Go's efficient. It works. It'll only compile in the bits it needs anyway. So why do I care? Well, let's take a very simple illustration. Here, we have 2 programs that do exactly the same thing. It's just a web service with a single endpoint that returns hello Gophers. One is written using the standard core library, one is written with Echo. Just making it clear, I'm not knocking Echo as a framework. It is a great framework. It's just, it was convenient, the syntax was clean, and it fitted on the slide. And again, you'd be like, well, they both work, so why does it matter? They're both about the same amount of code. It's not like Go routines where we've had to double our code or had to deal with extra stuff. It's fairly equivalent. But then you look at the Go mod files. And again, you go, Go's package service works, why do I worry? Well, if you need all that stuff, it's like your luggage. If you need it, fine. But if you don't need it, then every single one of those is a dependency that could go away. Every single one of those is a dependency that someone could stop supporting. Every single one is a dependency that could have a vulnerability in it. If you work in some particularly high-spec environments, every single one of those is a dependency that somebody's got to audit. Which, if you need them, is fine. But if you don't use them. And also, not even just withstanding that, you might say, just for example, I like Echo. I always use Echo. But maybe your problem doesn't suit Echo. Maybe it suits Go Buffalo or something else. And you actually find you code for a while with one framework and then have to spend more effort ripping that one back out to then use the one you needed to use to do the feature that you actually needed, or writing a whole chunk of custom code to get around the fact that that framework doesn't do the thing you wanted. So start simple. Bring the stuff in as you need it. I mean, as we've already seen in talks already, that the core library has some incredibly cool high-performance stuff in it, which, for the vast majority of cases, is fine. But if you've got need to step outside that, because anyone who saw the slog talk, it's like, yeah, if you need the high-performance, go with the zero log. But if you don't need it, just use what you've already got, and then layer it in as you need it. And if you do use libraries, again, try to pick ones that have good support, that have a good community around them, that have, if you're looking at GitHub, stars, and lots of commits, and ideally, closed issues, not just lots of open issues. And just as a last thing, I know I said, use the appropriate, say, framework for, the task in hand. So one service may use one framework, one may use another. That's fine. But for simple stuff, and especially within the same code base, don't use multiple libraries for the same thing. And mostly, my bugbear on this one is UUID libraries, because there are many of them, and the amount of pull requests I've seen that literally use two different ones in the same code is not funny anymore. For simple stuff like that, just pick one unless you have a need to use something else. And so to the green-eyed gopher of envy. And this follows on from our previous sin, because it's probably one of the commonest sins I've seen in Go, and the one I was very much the most guilty of when I first started coding. And it boils down to a tendency to write Go as if it was a different language. Yet again, you cry, why is that a problem? Because as long as it compiles and it runs and it has the features we need, who cares how I laid the repo out? Well, in most cases, again, it doesn't. But let's just take a simple illustration from my own checkered history. A long time ago, when I was a young Gopher, I was writing a testing framework. I don't know if any of you have come across Concordian. It's kind of like behavioral-driven testing with like human-readable specs, and it's all in Java. We used to use it at one of my old jobs, and I thought, that's quite cool, but could I do that in Go? And could I write something better in Go? So I started writing it, and of course I never finished it. It was a hobby project. You never finish hobby projects. But as I was going along, it worked. And it did the things I wanted to do. It read the specs. You could write them in pretty much plain English, and it would work. But it was getting harder and harder to add features. I started running into issues like circular dependencies. I started having to add extra interfaces and things around simply to get around those issues. Because the mistake I'd made is because my background was very object-oriented, ironically with Perl, I know, and Java, etc., I had tried to structure it as classes. I tried to lay it out as I would lay out, say, a Java program, which is not wrong, but I basically created barriers for myself. I then had to do a lot of rework, and to be fair, it's why I ended up abandoning the project, and I never really got that far with it, because it needed a fundamental rewrite, because I had a few hundred extra lines of code that just didn't need to exist because of the way I'd structured it. And even simple things like just purely code layout. And yes, this is chilling Matt's blog. On the left, we have some code written Pythonically, but in Go. And on the right, the exact same code idiomatically in Go. And I would hope you would agree that the one on the right is a lot clearer. It's a line shorter, even with the extra white space. It handles everything down the happy path on the left-hand side, which, if you do actually read the blog, that's what all that's about. This example is kind of ripped from that, but rewritten to be about puppers rather than whatever it was originally, which was just boring, so I thought I'd add puppers instead. And even something as simple as that, because neither of those two are wrong, but that one's going to be a lot easier for you to debug and for people to understand. That one is just noisy. Because I think one of the things I never liked about coding Python, and to be fair, you can actually write Python like you write Go, because I'd been trained to write it like this, is the errors at the end. Because in almost every case, you can short circuit, you can quit out early. Why do I need to read through everything to get down to the else error at the end? If anything, just invert the logic, even if you do nest. But again, when you're short-circuiting out the function, you don't need the else's, because it never gets that far. It shouldn't need to get that far. So, again, keep things simple. Don't adopt patterns unless you need them. Don't fall into the trap of going, I should be using factories and singletons and all those other things in the classical patterns book. Because they're best practice when they're useful and appropriate to the language, but don't try to shoehorn them in because you think it makes you a better engineer. It'll probably just make your life harder. Don't add interfaces for everything just because. Sure, if you need to mock something, great. But do you need to mock it now? No. Cool, add the interface later. Go is clean. Go is relatively easy to quickly refactor. You add that bits in when you need them, not just because. And if you haven't, read Effective Go. I mean, if you just Google that, I mean, it is linked in the slides, but if you Google that, you'll find it if you haven't read it already, which is kind of the guide to idiomatic Go. And I think the important thing there as well is the reasoning, because it's not dogmatic in the sense of this is how you write Go. It's this is how you should write Go because unlike a lot of languages, because Go is still relatively young, it was designed a certain way. It hasn't evolved and had bits bolted on and had to find best practice as it went along. Everything that's gone into it has been considered and thought out. Again, I refer you back to the slog talk earlier. It didn't just get shoved in. There was a lot of thought put into how it would interrupt, how it would fit with Go. And finally, we get to our Gopher sin of pride. And of course, I'm not saying taking pride in your code is a sin. That would be silly. This is more about assuming you know what's best. But I'm not talking about, say, going into a pull request and being like, no, you're wrong, do it my way. I'm talking about being overly opinionated in libraries. Because libraries and such are so easy to write and go, I would wager quite a lot of you have at least written something and probably got something on GitHub, GitLab, something out in the public. Maybe it's a hobby project, maybe something you intended to be a serious library for usage. And you made design decisions. Well, again, where am I going into what's wrong with that? And again, I'm going to say ultimately there's nothing wrong with that. But it depends on what those decisions are and why. Because to segue into another story, and to be fair, if you were at GopherCon a few years ago when I did my first talk here, I was working at the Office for National Statistics, which I will forever now refer to as the ONS because that's really hard to say. And for those of you that don't know, it's a large public sector organization. It's part of the government that deals with gathering and publishing statistics. I mean, generally the clue's in the name, but government, you never can be sure. And because it's a public sector organization, effectively all the code is owned by the British taxpayer. So the vast majority of it, apart from a few proprietary, commercially sensitive things, is all public on GitHub. If you go search for ONS Digital, I think they're still on the same account. I don't think they've changed it. You'll find a couple of thousand repositories. And so they've got a couple of thousand repositories and a few hundred developers. And of course, being a large organization in general, and especially being a government organization, they're constantly being attacked. So the last thing you want is to accidentally upload keys or secrets into GitHub. So, long story, way too late, too short. I wanted to write a tool that would go through and check that you weren't about to commit something you shouldn't to GitHub. But of course, being a good lazy gopher, I thought the best thing to do, virtuously lazy, not that, I thought, let's go and look if there's an existing tool. Let's see if there's something that's already there. And there kind of was, but none of them did what I wanted. Because in almost every case, they didn't quite work in the way I wanted. They almost all would only work on existing Git history. I mean, this was a few years ago. There's probably better tools now. And they would all search an existing history, but I wanted to make sure it didn't get there in the first place. So I thought, you know what? I don't have to use the actual tool. I can just use the checking routines that they've written in the library, because there must be the algorithms for working out the secrets in that library. Cool, I'll just write my own tool using them. But I couldn't, because they were all private. Because the author of the package just thought, well, you run this by using my tool. Why would you want access to those? So ultimately, gratuitous plug, I ended up writing my own utility, which I still use to this day. And to be fair, it was great fun, great, little exercise to find the actual algorithms, work out how to implement them and go, and it works. But I shouldn't have needed to if those libraries had just exposed those functions. In a similar vein, a while ago, I wrote a Slack bot, which is something I'm sure we've probably all dabbled with at some point in our career. And I needed something to write it about. I needed it to do something. So some of you have heard of Eliza, one of the first chatbots. Tried to, psychoanalyze you. It was really, naive parser, etc. So I thought, I'll implement that and implement it in the Slack bot. So when I did it, I split it into two libraries. One is the actual Slack bot, which just contains the code that makes it run as a Slack bot. And the other is the pure implementation of ELIZA. So if you want to come along and write a Teams bot or a Discord bot or a command line app that does ELIZA, you can just use that one. Because I thought at the time, I don't want to hide this away from people. I don't want to make it harder for them to use. I want people to use it, but they might not want a Slack bot. So, just made a better design decision, in my opinion, to make that code available. It could have been one repo, to be fair. 2 repos was probably overkill. But, it's cleaner. I know, back in my Gopher youth. So if you are writing libraries, don't artificially restrict access. I'm not saying make everything public, because anything you make public, you have to support, because it's your public API. But if you've got like general models, like if you've got a JSON schema model, it's a standard model. Don't make it private, because someone else might want to use it, but they might want to use it in a way that you didn't originally intend, and that's fine. And as a slight aside, if you are going to write something that's suitable for Go routines, don't run Go routines in your library. Let the user choose if they want to run your functions as Go routines. Because if you're trying to unit test something that uses Go routines, it can be an absolute pain. And also, they might not want to run it as a Go routine. Don't make that decision for them. And lastly, we get on quickly to the last sin, which, yes, if you're counting now, makes 8, and I know I said 7. Because this is really the meta sin. This is the sin that surrounds us, penetrates us, binds the sin together, as it were. Star Wars reference, if you didn't get it. And that is the sin of complexity. Because pretty much everything on this list, there's nothing there, unless you're in some particularly highly sensitive situations, there's nothing there that's going to get you fired. There's nothing there that's going to cause your office to explode. If there does, you've really done something wrong. Pretty much all of them just lead to complexity. Because, again, Go routines are powerful when they're useful. If you just add them because you think you should, or when you don't need them, you've added complexity. If you pull in libraries you don't need, you've added complexity. If you don't comment your code well, you've added complexity. But just before we finish off, because some of you will be sitting there thinking, oh, yep, I did that one yesterday. Oh, I'm a terrible programmer now. Don't beat yourself up over it, because like I say, I've done most of these. That's how I know about them. And hopefully, this will help you avoid some of them. But probably the last takeaway is that the road to complexity is paved with good intentions. Because in every case of those sins, you did it because you thought it was for the best. You weren't trying to write bad code. You weren't trying to make it complex. I mean, you might have done, I'm not assuming. But generally, whenever I've seen this, it's from somebody trying to do the right thing. For example, they've added Go routines because they thought they needed the performance when Go was probably performant enough. Or they skimped on comments because they were trying to get the work done faster, fix a bug faster to get a feature out. Pulled in a library because they thought it was best practice because it would get stuff going quicker. Used generics because, oh, this is the new thing. Everything should be using this because this will make things so much more flexible. So, if you are guilty of any of these, just don't worry about it. Just learn from it. Move on. Write a conference talk. The usual. And with that, that's me. I mean, that is me as a Gopher. Thank you.